Today we're going to talk about function notation, and you may or may not remember this from Algebra 1, but functions are tools that convert inputs, which are the x values, the independent variables, to outputs, which are the y values, the dependent variable. There's a special notation which we use to represent this process, function notation, and it's like a condensed down but not as cool looking function machine. We're going to put something into the function to determine what comes out of the function, and different teachers have different ways of saying it. But this f right here, first of all, it's read y equals f of x, is what I call the name of the function. And typically we talk about the f of x, or g of x, or h of x are the most common, and that's what we're going to use today. And looking at the box here, that doesn't really necessarily tell you how to work with this. And so that's what we're going to spend probably the next 10 minutes or so talking about. So how do we use this notation? Well, f of x equals 5x minus 2. So there's our function, the 5x minus 2. And what's going to happen here, I want to make this a little bit bigger, what's going to happen is that we are going to put 3 back into our function wherever we see x. Notice the notation, f of x, what's right underneath it? The 3. So we're going to take this value of 3 and we're going to put it back into the function wherever we see x. So this is going to become 5 times 3. There's our input. And when we do this calculation, that's going to determine what our output is. Well, 5 times 3 is 15 minus 2. And 15 minus 2 is 13. And if we want to get really technical about this, f of 3 equals 13. We put 3 into the function, and we get 13 out. Now, if it's not written quite so nicely, like the f of negative 2, and again, notice my wording, f of negative 2, then write down the function again, 5x minus 2, and maybe remind yourself that this is f of x, and ultimately what that means is that negative 2 is going to replace the x over here in our function. So we're going to put negative 2 back in here for x. So now it's going to be 5 times negative 2 minus 2. And 5 times negative 2 is negative 10 minus 2, which is negative 12. And once again, if we want to get really technical, then f of negative 2 equals negative 12. If we look at another one, this time our function is g. So we have g of x. But notice what we've got here. The 6 is where the x was originally. So we're going to take this value of 6 and we're going to replace x back in our function with 6. So that 6 is going to go back in there for that x. This becomes 6 squared plus 4. And remember, squared means times itself. This is 6 times 6, which becomes 36, plus 4, which is 40. we put 6 into the machine, we get 40 out of the machine. So g of 6 equals 40. We can do the same thing with g of -1. And what might be helpful, since you're not writing directly underneath the function, is to write the function again, which is x squared plus 4. And a reminder that what we're using here is, this is g of x, so we're going to take the -1 and we're going to put it back in, or we're going to put it in to the function to determine what we get out of the function. -1 is going to go in for that x. So it's going to be -1 squared plus 4. And be careful. If you're typing that into the calculator, you have to have parentheses around that term. But -1 squared means -1 times -1, which is 1, plus 4, which is 5. And ultimately here, g of -1 equals 5. We put -1 in, we get 5 out. So let's try one more. H of x. Again, common names of the functions. The rule of the function is they're typically f, 4, g, or h. But once again, notice where the 5 is located. H of x, then it's h of 5. So what we're going to do is we're going to take this value of 5 and we're going to put it back into our function wherever we see x. So this is going to be 3 times 5. And the thing about this one is, we can't do much else. 3 times 5 is 15. Some of you may remember simplifying square roots, but we can't simplify this one. If you type it in your calculator, you get a big long decimal, so we're going to leave it like it is. But if you did or were able to simplify it, we would like you to simplify it. But right now what we're focusing on here is that we put the 5 into our function, and this time we're going to get out the square root of 15. And let's use the h of 0 here. And a reminder, it might be helpful to write the problem down again. Square root of 3x. And what we're doing is we're going to put the value of 0 back into our function for x. So this becomes 3 times 0. Well, 3 times 0 is 0. And can we take the square root of 0? And we actually can. It just is 0. We don't have to write the square root symbol anymore. So in this case, our input of 0 gives our same output of 0. And what we're given in these particular examples is we were given the input and we came up with the output. But we can be given the output as well. It says, be careful not to confuse this notation with multiplication. Just take what is in the parentheses and substitute that value in for the independent variable, then solve as usual. That's what we did. But we can go backward. We can be given the output, and we can go back to figure out the input, This is just like when we look at y equals equations and we're asked to solve for x. So our function, f of x equals 5x minus 2, it says find x when f of x equals negative 27. So now where we're substituting is we're going to take this value of negative 27 and we're going to put it back into our equation where we see f of x. So we need to really be careful when we're reading a practice paper or we're reading a skills quiz or even a test. Are you given the input or are you given the output? In this case, we're given the output. It's going to be negative 27 equals 5x minus 2. And we need to solve this equation. So we filled in our output in this case, which is the f of x. And now we want to figure out x, which is going to be our input. And in order to do that, we're going to add 2 to both sides. And we have negative 25 equals 5x. It's 5 times x. The inverse operation is to divide by 5. And we end up with our input of negative 5. Let's try another one. And for the most part, people do quite well on this. But I need to really stress the fact that we need to look and decide, do we have input or do we have output? And in this particular section, we have output. Find x when g of x equals 53. So this 53 is going to go back in to this part of the problem, not the x. And we have x squared plus 4. When we solve this, we want to isolate our x, so we're going to subtract 4 from both sides. 53 minus 4 is 49 equals x squared. And what we're looking for is what number times itself equals 49. So you might be able to get it that way. So a few told me, here, square root this side, square root that side. The other thing is 7 the only value when we square it gives us 49? If you think about it, positive 7 times positive 7 is positive 49. But negative 7 times negative 7 is also positive 49. In this case, we could have 2 inputs. Typically, we tend to deal with the positive input, but we'll put them both there. Again, watch out for what you're given. Are you given the input or are you given the output? In this situation here, we were given the output. Same kind of situation. We're given the output in this particular situation. H of x equals 6. We need to take the 6 and put it back in for h of x. So we end up with 6 equals the square root of 3x. And in order to solve this equation, it's kind of the reverse of what we did on the last problem. What we can do to get rid of the square root is we can do its inverse operation, which is to square right there. And if we square the right side of the equation, then we're going to square the left side of the equation. Square rooting and squaring cancel each other out. 6 squared is 36, because it's 6 times 6. Well, 3 times x, the inverse operation is to divide. We're going to divide both sides by 3. And we get x equals 12. Our input is 12. Our output is 6. Now what we've been dealing with on the front of the paper are functions written in equation form. As we turn our paper over, we see that they don't always have to be written in equation form. They can be written as graphs or tables, and that's what we're going to work with mainly here on the back of our notes. And our first example says boiling water at 212 degrees Fahrenheit is left in a room that's 65 degrees Fahrenheit, where it begins to cool. Temperatures readings are taken each hour and are recorded in the table below. Here, temperature is a function of the hours. So when we leave the water initially, it's 212 degrees. We go to the next space over where we see 1 hour, and now our temperature is 141 degrees. And then at hour 2, it's 104 degrees. In hour 3, it's 85 degrees, and so forth. It's how we can look at this. And on part A, it says, evaluate T of 2 and T of 6. So what that means when we see T parentheses 2 is it's what is the temperature at hour 2. And maybe you need to write that down, and maybe you don't need to write that down. But what happens is once we know what that terminology means, we go up to our table when we find 2 hours. And we look below the 2, and what we see is that hour 2, our temperature is 104 degrees. Hour 2, the temperature is 104 degrees. And that's the same concept here when we do T of 6. Notice how I'm reading it. T parentheses 6 means T of 6, not multiplication. So we go to where we find 6 hours, which is in the top of the table. We go to the 6 in the top of the table. And then we look at its corresponding temperature underneath. And we see 68 degrees. Now, our input was 2. We get out 104 degrees. Our input was 6. We get out 68 degrees. Look at part B. For what value of H is T of H 76? So we're trying to find how many hours until our temperature is 76 degrees. So this time what we're doing is we're looking at the bottom of the table. And as we look at the bottom of the table, we find the 76 degrees in the bottom of the table. And then we look above. And what we see is that it's going to be 4 hours. Part C. Just becoming more familiar here with these. The top row is the hours. The bottom row is the temperature based on the hours. It says between what 2 consecutive hours will our temperature be 100? The time T of H. So T of H is even labeled in our table over here. And it's not going to be between hours 0 and 1, because we're going to go from 212 degrees to 141 degrees. And it's not going to be between hours 1 and 2, because we go from 141 degrees to 104 degrees. But we're getting closer to 100. From hour 2 to hour 3, we go from 104 to 85 degrees. So between what 2 hours? It's going to be between 2 and 3 hours. look at the description on your table when you're doing these problems. It will be helpful. Number 4. Y equals f of x is defined by the graph below. Answer the following questions. So now we have to think back. Is this picture a function? Got a couple of yes? How do we know? And I'm going to keep it really brief. Excellent. Going to write VLT for vertical line test. Vertical line test. Don't write this in on your paper. Just a reminder from Friday that no matter how many vertical lines we draw, it never touches the graph more than once. And because it never touches more than once, that means that it is a function. Well, is the function 1 to 1? And how do we know there? It's the other one, which I'm going to write HLT for horizontal line test, abbreviation. Again, don't write this in on your paper. It'll just be confusing. But the horizontal line test says, as long as a horizontal line never touches the graph more than once, it will be 1 to 1. But we touch it here, and we touch it here, and we touch it there. One time at least. It touches 3 times, which means that it is not a 1 to 1 function. But we're still going about the same kinds of things that we've been doing with our equations, with our table, and now a graph. This says f of 1 for our first problem. Remember, f of x. That means when x equals 1, what is 1? That's how to read it. I mean, that's what it means. I mean, it's read, evaluate f of 1. So we come over to our graph, and we go over 1. So what value is on our graph at 1 when x is 1? 1, 2, 3, 4. So f of 1 equals 4. Same here on the next value, f of negative 1. Well, we'll go left on our graph to negative 1. We want to know what y is when x is negative 1, and it's 0. Well, f of 5. 1, 2, 3, 4, 5. Finding the y value when x is 5 is 1, 2, 3, 4, negative. Now, let's answer a couple questions. It says, evaluate f of 0. Well, that's the same thing that we've been doing on part B. F of 0. So, 1, 2, 3. F of 0 equals 3. What do we call that value on our graph? Well, it's called the y-intercept. Now, the next one says, what values of x solve the equation f of x equals 0? So when we look at this question here, what values of x solve the equation f of x equals 0? Essentially what this is asking is, when y equals 0, what is x? And if we go back and look at that picture there, It says list all of them. Well, here's a place where y equals 0. Here's a place where y equals 0. There's a place where y equals 0. You don't have to list them in the same order as me, but make sure that you have all of them. In this case, it's -1 and 1, 2, 3, 4, 5, 6, 7. And if you compare this back to what we were just doing a moment ago on part C, we said, what special point on the graph does this correspond to? Same kind of thing here. What special points do these correspond to? Well, these are x-intercepts. Where does the graph cross the x-axis? So now let's try one after having seen one and see if we can apply it, because that might have been the first time that you have done those kind of things. I do have one typo here. It says evaluate each of the following using the graph of g of x to the right. And then I have all f's down here, so we're just going to change this to f of x to the right. But see if you can work ahead of me. What does f of 0 equal? See if you can get it before me. Did you get 4? And what does f of -3 equal? See if you can get it before me. It's going to be -2. F of 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. Now, watch out on part B, because B is giving us an output. What values, find the values of x when f of x equals 2. So it's the y value is 2. And one thing that might be helpful for you, I don't want to use red here, but if the y value is 2, it's going to be here. And in fact, we've got a value there when y is 2 of 1, 2, 3, 4, -5. Here's another value of 2 when x equals -1. Another value of 2 when x equals +1. And another value of 2 when x equals 3. Part C. For how many values of x does f of x equals 3? Again, we're given the output is 3. We need to find the input. This time, all that we want to know is how many. But once again, you might want to draw in the vertical line, because here's f of x equals 3. What we did previously here is we had f of x equals 2. But the question isn't what are the values, and it's hard here to say what they are. It's just how many. We've got a value there, we have a value there, and we have a value there. We can't be specific on what they are, but we can be specific on how many. 1, 2, 3 of them for 3 values of x. And lastly, a multiple choice question to finish. For a function y equals g of x, it is known that g of -2 equals 7. Which of the following points must lie on the graph for g of x? Well, one last time, g of -2 comes from g of x. And -2 is where the x would be. So that means that x is is going to be negative 2 in this problem. And as we look at A, there's not a negative 2 in A. There's not a negative 2 in B. So we narrow it down to C and D. And then it says our output is 7. Well, the only two values remaining that have 7 means that our answer is going to be C.